In this problem we're asked to simplify, which looks like what we're doing will be adding a trinomial to another trinomial. Simplify basically can be boiled down to simply getting rid of parentheses and then combining any like terms. So I'm going to insert my understood 1 in front of the parentheses, and then when I multiply through, I no longer have parentheses. So 1 times 3x squared is 3x squared minus 2x minus 5. Then we want to combine our like terms, so I'm going to take my 2x squared and my 3x squared and add those together. That gives me 5x squared. Remember, by adding we'll never change exponents. My 3x plus my negative 2x, or 3x minus 2x, is 1x. And then I have a negative 4 combined with a negative 5, which gives me negative 9. Now what I want you to notice here is, even though I added the ones and distributed, it really didn't change any of the values there. So what I could have done is simply add the like terms together. Let's look at another example. We'll take 4x squared plus 2xy plus 3y squared. We'll add that to a 3x squared minus 6xy plus 2y squared. So since I notice it's addition, I'm simply going to take the x squares, combine them for 7x squared. A positive 2xy and a negative 6xy combine to give me negative 4xy, and a 3y squared combined with 2y squared gives me 5y squared. Those don't seem to be a problem. Where people make mistakes sometimes, though, is when what we're asked to do is to subtract polynomials. So 2x squared minus 3x plus 4 minus a 3x squared minus 4x minus 5. Now we could do that without inserting our 1's, but sometimes that leads to problems when what we have to do is subtract a negative 4. Sometimes students forget that to subtract a negative is really to add. So in this case, it really does sometimes help us to go ahead and insert that 1. When I do that, I get 2x squared minus 3x plus 4. The positive 1 doesn't change. But now I'm distributing a negative 1. So I get negative 3x squared, a positive 4x, because negative times negative is a positive, and negative 1 times negative 5 is positive 5. So now I see I've got 2x squared combined with a negative 3x squared, that is negative 1x squared. I have a negative 3x combined with a positive 4x, that is a positive 1x, and then I have a positive 4 combined with a positive 5, that is positive 9. Now I want you to notice that I could have gotten the same thing without doing the distributive. I would have done 2x squared minus 3x squared, which gives me a negative 1x squared, just like I had here. I would have had a negative 3x minus a negative 4x. That would be negative 3x plus 4x. That's where I got my plus 1x. And then I would have had a 4 minus a negative 5, which is 4 plus 5, or positive 9. So I would get the same thing. But doing this sometimes gives people trouble, especially when they're trying to do it in their head, and that's the reason I suggest inserting the 1's, using your distributive property, and then that takes care of that minus and negative. We have already made that plus, and so it makes it a little bit easier to work.